Behind the scenes of our hyper-connected world, in server rooms and data centers you'll never see, there's a hidden army of technicians. They're the ones literally keeping the lights on. Today we're going to pull back the curtain and look at the high-stakes world of the massive batteries that are our last line of defense against a total blackout.
So let me ask you a question. When a storm rolls in, when the grid gets shaky and the lights flicker, what's the one thing that stands between our normal, functioning world and a complete standstill?
Because here's the thing. When the main power grid goes down, and it does, a whole second, invisible power source has to kick in. And I mean instantly. We're talking about these silent guardians that make sure our hospitals, our data, our life support systems stay on.
And those guardians? They're called uninterruptible power supply batteries, or UPS for short. Now, I'm not talking about that little black box under your desk. No. We're talking about massive, room-sized battery banks that are the final wall between order and chaos.
Just think about where these things are deployed. These systems are absolutely critical in places where a little power flicker isn't just an inconvenience, it's a full-blown catastrophe. We're talking about hospitals keeping ventilators breathing for a patient, or an air traffic controller needing to see every single plane in the sky. These batteries are truly the unsung heroes protecting our daily lives.
And the stakes? They are just staggering. A stock exchange can lose millions of dollars in a single minute. A data center outage can cost a fortune. But for a 911 call center, well, that cost is measured in human lives. In this world, failure is just not an option.
But here's the deal. Keeping these systems at that 5 nines, 99.999% reliability, it takes a special kind of professional, someone who is willing to face some pretty incredible dangers to get the job done.
These technicians work with an immense amount of power, often right next to live 480-volt DC bus bars. Now, unlike the AC power in your house that kind of pulses back and forth, DC is a constant, relentless flow of energy, and that makes it so much harder to stop an arc once it starts, which leads to way more violent electrical events.
And when I say violent, I am not exaggerating. A dropped tool, just one moment of carelessness, can create something called an arc flash. It's basically an electrical explosion that unleashes this wave of heat, light, and molten metal. It's truly one of the most terrifying things you can witness in the electrical world.
And it's not just the electrical risks. Technicians are dealing with hazardous stuff like sulfuric acid and explosive hydrogen gas that the batteries can give off. Plus, there's the sheer physical strain of moving batteries that can weigh over 600 pounds, and they're often doing this in server rooms that are blazing hot. It is, without a doubt, one of the toughest jobs in critical power.
So how on earth do they do it? How do you tame that kind of power and work safely in such a hazardous place? Well, it all comes down to a combination of skill, incredible precision, and having the right gear. You have to understand, this isn't just a job, it's a discipline. Every single piece of their gear, their personal protective equipment, from insulated gloves rated for crazy high voltage to acid-resistant face shields, it's all a layer of defense. And procedures like lockout/tagout, those are non-negotiable, golden rules that make sure a system is totally de-energized and safe before anyone even thinks about starting work. A battery replacement is the perfect example of this. It's this meticulous, controlled process. Every single step, from disconnecting old batteries in the exact right order to torquing the new connections to precise specifications, is designed to maximize safety and reliability. It's like a technical dance where every single move matters. So, you might be wondering, what kind of person signs up for this highly specialized, kind of dangerous job? You're probably thinking it requires years and years of advanced college degrees, but the path to becoming one of these pros is actually way more accessible than you might think.
That's right. This is a career that's built on skill, on training, and on hands-on competence, not on a specific 4-year degree. In fact, it's one of the most direct ways to get into the exciting and absolutely vital world of field service engineering.
So what's the game plan look like? Well, it starts with a solid foundation in the basics of electricity. From there, you can jump into a trade school or an apprenticeship to get that crucial hands-on experience. Then you get critical safety certifications, like NFPA 70E for arc flash safety. And finally, you do on-the-job training where you learn directly from the seasoned pros. It's a really clear, attainable journey. And look, for anyone who's seriously thinking about starting this journey, there is an essential field guide. This book, Mastering Uninterruptible Power Supplies Field Service Engineering, is basically the fast track. It is packed with real-world procedures, checklists, and stories straight from the field, and it's written by an expert who's been there and done that.
So, if any of this has sparked your interest, this is your next step. It's the kind of practical, real-world knowledge you just can't get anywhere else, and you can find it exclusively on Amazon.
Behind every screen you look at, every credit card swipe, every emergency call, there's a system that simply cannot be allowed to fail, and it's maintained by these professionals who work in the shadows. We've shown you the dangers they face and the incredible skills they have. So the only question left is, are you ready to be the one who keeps the lights on?